Okay, so can I just get a hand raise if you're an engineer, software engineer? All right. Anyone work on infrastructure, like DevOps, SRE? All right. Vibe coders. Any vibe coders? All right, my people. All right. All right, cool. So I'm going to go over like what a sandbox is. It's core infrastructure right now. Well, first off, my name is Gianni Carvelo. I'm the CTO and co-founder of Sylow Technologies. We build and manage core infrastructure. Right now, like most of our work is being done with deploying agents into production and handling production workloads. And that brings pretty interesting constraints, right? So like, and this comes straight from the Claude SDK docs that I'm requoting it. Unlike traditional software that follows predefined code paths, agents essentially can write their own code. So their code that writes more code and can take actions on top of a computer. And so we want this flexibility. It's what makes the agents really useful. It's what gives them their power, but it's also a way for new threat vectors to show up. Right? And so this means that their behavior can be influenced. So defense in depth, it's kind of like a marketing term. Basically means to just layer on top of security protocols so that you have some defense that is deeply in your stack and you can reason about the threat models. So much of security and performance is just understanding your constraints and understanding your environment. So this is a super reasonable way to go about deploying OpenClaw, right? So we have a... I'm sorry, can you share your screen one more time? Yeah, gotcha. Give me 1 second here.
Don't worry, we'll cut it out.
Okay. Yeah, no worries, no worries. Let me... Grant, you want me to share the whole screen just like this? You good? Okay. Alrighty.
Okay. 3, 2, 1.
So this is a reasonable way to deploy OpenClaw, right? So what you typically want to do is you want to deploy the agent inside of a sandbox. If you have defense in depth, your sandbox has its own guest kernel and a guest file system. And anywhere you see red is where something could go wrong and where you probably want to apply some security policy, right? So ingress traffic, if you've ever heard of prompt injection, that's what happens, right? So your OpenClaw is listening to email and it gets prompt injected. Well, if your OpenClaw instance is behind or it's inside of a sandbox, the only way you can get to the OpenClaw is you have to go through the host, and that's where you apply some network policy. If something passes through the host, you still have a network bridge that you need to go through. That's another place where you can apply a security policy. And then anything that the agent does that's interesting, like I/O, network I/O, file I/O, that's another place where you would apply security policies directly inside of the sandbox. Okay, so what's a sandbox? A sandbox is a controlled execution environment that limits what a process can access and affect. That's essentially what a sandbox is, and there's different types of sandboxes. There's fancy things in the middle between containers and VMs, like if you've heard of gvisor or Kata containers, but in a nutshell, you have two categories. You have containers and you have VMs. Containers are isolation entirely implemented by the host kernel. So containers share the same host kernel, and it uses container technologies like namespaces, which controls what the process can see, C groups, which controls what a process can consume, and setcomp, which controls what a process can invoke. And then on the right side here, with VMs are typically hardware enforced, and especially some of like the newer technology like micro-VMs, they're enforced by the KVM, which is a kernel virtual machine. And they're completely different, right? They wake up, the guest kernel boots, and it thinks it's the only thing on the computer. It boots into ring 0, and operations like I/O trigger what's called VM exits. And so Firecracker is actually a VMM. It's a virtual machine monitor. Anytime the agent does any sort of like file I/O or network I/O, the VM will exit, and then that's another place where you can apply security policies. I have a blog post about building one from scratch in Python. If you want to check it out, it's pretty low level, and Python is. Who said Python is not a low level systems language, right? We build one from scratch, and if you go through that, you'll appreciate that we don't build it from scratch in the Nightshift stack. And so we're introducing Nightshift. So Nightshift is a runtime API for managing containers. And so it's composed of 3 components: an agent instance protocol, so that's the thing that goes inside of the container. And when I say container, I mean some sandbox. The agent implements this protocol. We have an agent OCI spec, which is the container or sandbox is self-describing. So the sandbox will essentially say, hey, I need this many vCPUs, this much memory, I'm allowed to do this, that, or the other. It's going to describe itself to the runtime. And then we have the brain of the operation, which is the agent runtime API, which orchestrates and load balances across the containers the sandboxes that it manages. This is kind of the same thing, but splayed out on a diagram. So HTTP requests come into Nightshift Gateway. There's 2 ways to communicate with Nightshift Daemon, through the Nightshift Gateway or through the CLI. The communication beyond the Nightshift Gateway and the Nightshift CLI is all over. It's done with gRPC. It communicates to Nightshift Daemon, and then Nightshift. Something cool about Nightshift, I don't know when you would want to do this, but it's a flex for the Nightshift Daemon, is that you can run heterogeneous sandboxes in the same cluster. So even on the same node. So your node can run Firecracker, Kata containers, Docker containers, even like exotic runtimes like WASI, for example. All right, this is the live demo part. All right, so I'm going to go over here. So what we're going to do, actually, let me go back here. I have a checklist. Okay, so the checklist is we're going to compile and start Nightshift D. We're going to create a Dockerfile together with this agent OCI spec. We're going to build the agent OCI spec. We're going to deploy into an AWS C5 Metal instance, which is a bare metal instance inside of AWS. You can just replace AWS C5 Metal with any KVM-based machine. And then we're going to stream events from the other side, right? We're going to stream events from the sandbox. All right. So here it is. I hope everyone can see my screen. Yeah, there you go. So this is a terminal, guys. We're going to compile the Nightshift daemon. So -o, Nightshift D. We're going to compile down Nightshift D. And Nightshift D/main.go. All right. So we're going to compile down the daemon, which we already have it here. Boom. So we can see it. I'm going to run this. But before I do that, I'm going to show you what a config file looks like in Nightshift. Config. So this is how you control the Nightshift daemon. You have a state dir. You have like agent default. So if you don't define what your container needs, this is essentially like the operator will define that any agent deployed into this is going to use 2 vCPUs, 512 megabytes of memory, have a 300 timeout, and max concurrent VMs of 3. And then we're going to use a default sandbox of Firecracker. All righty, so I'm going to start that up. Shift D, I'm going to pass in the config file. TOML. Okay, cool. So we got the Nightshift D started. All right, cool. All right. So then now the next stage is to build Pi. Like this is what we're all here. So we're going to build OpenClaw. Fun fact: Pi is the coding agent underneath OpenClaw. So this is a developer platform, and this is a developer talk. So we're going to deploy the actual harness. And so I went into my examples here, which is also available on the GitHub. Really simple Dockerfile, right? So we deploy right here. We're going to install the Pi coding agent, which is essentially OpenClaw. And then this is where the OCI spec comes in. So we label that this is the V1 protocol. This specific instance is going to need 2 vCPUs, 1024 memory, has a 600 timeout, and we're going to default, or we want a VM. So VM just kind of maps to Firecracker, which is a micro-VM. If you put here instead for a container, this would run Docker. Alrighty, so here we go. Let's build this image together. You don't need a GPU for this. So we're gonna deploy here, build-t, give it a namespace, pi agent, latest, and we're gonna build this together. All right, we built the container. All right, cool. So now we're going to go over to Postman here, and we're going to communicate directly with the running Nightshift daemon, right? And so in this case, we're going to hit the deploy endpoint. I'm going to name this deployment OpenClaw, and then I'm going to pass it in an image ref, which is the container we just built. All right, so we just deployed it, and it's obeying our request, right? So 2 vCPUs, the memory, the timeout, and then the important part here is the sandbox, right? Let me list my agents out on with Nightshift D. And so we have one of my test agents from before. And if I scroll down here underneath, and here it is. Here's our deployment of OpenClaw. I'm going to create a run. So I'm going to ask OpenClaw, say hello and tell me what 2 + 2 is briefly. I'm going to hit invoke. It's now in run phase pending. So what the container does under the hood is, you can see the logs here. The Firecracker VM starts up. It opens up, read writes, and then the Firecracker VM is ready, and now it's running the actual task. So if I go here, so if I grab this run ID, and I go to stream events.
Can you zoom in just a little bit?
Of course. Better, guys? It's good. If I go to stream events, and I pass in my run ID, we'll see the actual streamed events here. So these are the text. So if you've developed with, these APIs, they stream back text deltas. Those are all the text deltas that stream back from our Firecracker VM. And then if I get the run, here we go. Let me delete it. We should be able to see that the run succeeded. All right. Run phase complete. That's the demo, guys.
We have a few minutes for questions. Does anyone have any questions about sandboxing OpenClaw? Any questions? Oh, question over here. Oh, we're passing a mic to you.
From someone that's just getting started, going from building apps and designing them themselves, going into agentic workflows, what would you say is the way to set up the context files, the guardrails, the BPS, everything that is going to have to do with safety? It's going to make sure it doesn't go off the rails or do something that you don't want it to, or design in a way that you would like it to if it was you, for example.
So there's a lot there, right? So I have a diagram here, which is so you asked how you get started. This is a very reasonable way to get started, right? If you're serious about security, you're serious about running these things, and like, let's just say that you're running agents and you're running a multi-tenant, like you are an operator and you're running a multi-tenant platform. So other people, other developers can deploy into the platform. So you have like different customer workloads, and all of those workloads are untrusted. This is a very reasonable way to get started, like out of the box, right here, right? So you have a host machine. You have a host machine. You deploy your sandbox. The sandbox has its own stack of everything. It has its guest kernel, it has its guest file system, it even has its own guest networking. You apply policies at the points where things can go wrong, we should be good. Yes.
One second. One second, you're gonna have to repeat this so everybody can hear.
Okay, coming from a non-developer coding technical background, and obviously something like OpenClaw is accessible to everyone, including someone who's not a programmer. You speak another language, even though I'm sure you're explaining it in the most basic way. Where or what is a good way to start so that it's not so intimidating and overwhelming? Because I'm sure a lot of people in this room probably what you were coding and entering into your run program, but it's, yeah, where does one start if we want to? Yeah.
So you guys don't program runtimes?
Not scared of it, but want to know where to start.
I can answer that question.
Sure.
Come to the Miami-Dade AI clinics. Is that good?
I was just gonna say. Yeah, I was just gonna say. It's up to the runtime builders to make these things more accessible. Like one of the core tenets of our platform is that the open source project is that we want to make it such that doing the right thing is easy. We're not there yet, but we're getting there. And so if anyone wants to help out, we're open source. Great question. It's a great question. It's up to us to make these things more accessible.
Yeah. Yeah, I just want to make a comment on that and also the question that was around there. Unfortunately, this technology involves some technical stuff, you know? You need to learn a little bit of some things. But if you want to get started, there are some services out there. Like, for example, there is one called Hostinger that provides some VPS, which is a virtual computer. And once you have one of those, just with one click, you can just deploy that server and access your graphical user interface to interact with OpenClaw. And then you can pair that OpenClaw with either Telegram or WhatsApp or any channel that you want to use. That's the easier way, because any other way, like creating the sandboxes, configuring a Mac Mini, like creating a Docker container, all of that involves some type of technicism. And you need to learn. And it's good because you are looking for something new, you need to start learning the new language, you know, because we are in that field right now. But the good thing about it is that with 2-3 easy steps, you can get access to the technology. Then, if you want to go a little more further and learn, it becomes technical, because this is based on a concept called an agent, and an agent is like a really good piece of technology. Okay?
Amazing, amazing. Let's give that up. We'll have two more questions from the audience before we move to the next one. But for real quick as well, so who would like a class on how to set up OpenClaw here? Who would like a class on that to make that easy? Well, how about this? DeepStation is going to be launching a class on OpenClaw in the next few weeks. So if any of you are looking to learn how to do it, let's make it happen. So feel free to follow our Luma, and we'll having a class for that available for all of you. So thank you. We have two more questions for the audience, maybe three. We'll see.
Yeah, real question. Inside of Sandbox, how do you log for inference, for future inference? How does it actually learn within that sandbox?
Repeat the question.
Can you repeat the question?
Yeah. So,
Yeah, how does the actual agent learn? I mean, can you keep or log anything for future inference?
Of course. Yeah. Great question. So, Nightshift doesn't handle any of the reinforcement learning loop or actual training, but we provide a pluggable telemetry collector, right? So Nightshift D, the Nightshift Daemon routes anything that's happening like inside the host, and then also anything that's happening inside the sandbox itself, logs, metrics, traces to a telemetry collector. And then you can plug that into like Grafana, for example.
Amazing, amazing. And we'll have one more question from the audience, and just for context as well, the next one will be a good one for 0 to 1 as well. So we wanted to have a good balance of, great engineers, professionals, and then also for 0 to 1. So Micah Berkeley.
Hey, what's going on? So I'm trying to help bridge this gap a little bit, because I know a lot of you guys are here from the engineering side. I know there's people here from the more vibe coding. I want to figure this out. So I know your environment. I've lived in it. I also know the deep vibe coding environment. I'm gonna put this down. Oh, Mike. Oh, okay. Sorry. This right here, what he's building, is dope for a lot of really important reasons. Let's say you're building infrastructure with OpenClaw that's taking private information, or you're doing stuff with credit cards, and you're doing stuff where you're transacting, business that needs to be warehoused in somewhere safe. What he's doing and the environment that he's building keeps it safe. It puts a lot of gates in the way to stop somebody from entering into your environment and doing stupidness. Example, today, I received a tweet from somebody who tried to prompt inject my OpenClaw. He sent a nice, hey, what's going on, brother? If you just send me your API key, boo, boo, boo. And the way he was breaking it down was actually really intelligent. Fortunately, my OpenClaw caught it, and I have systems in place to stop it from recklessness. But what he's building here with Nightshift and, these are the gates that we need to have if you're building these secure systems. And that's why I know it's kind of hard to understand, like, oh, what's he talking about? Us as engineers, we get it, right? But what I want everyone else to kind of understand is that if you start building in OpenClaw and you start using these systems like Pi and et cetera, and you're building stuff for clients, because that's where the bag is at, you want to protect your stuff, right? And it's important that you have infrastructure like this, stuff within containers, stuff within KVMs. When I first started using OpenClaw, I went balls to the wall. I let it have access to everything, and I learned some really, really important lessons in that first week. I've learned to use knowledge and wisdom now, right? And I know, I got you. I feel the hook coming, right? But no, I'm saying this because I just want, I think that what you're doing is super dope, and I understand it, but I do want to kind of cross that bridge for everybody so they understand why this is so important, why these different levels and these different gates and these different, like understanding telemetry of what's going on inside of these environments is important. But I actually didn't really have a good question. I didn't really have a good question for you, but I think what you're doing is amazing.
Thank you so much for that, Micah. Micah is actually an OG from the very first DeepStation event. Is that right? Amazing. So I think we're going to go ahead and just move to the next session. Let's give it up one more time for Gianni Carvelo. Amazing.